Hey folks, Mr. Anderson back one more time with what is going to be our last video in Chapter 9, Section 9.4.1. Of course I can see, and you guys can see as well, that there are more sections in Chapter 9, but we've got a couple of in-class items planned for these because there's some really cool stuff happening there that really works well for in-person. So we've got a opportunity today to check this out and take more than one inequality and graph it at a time. And this is going to create a system of inequalities for us. So something really cool. We've seen system of equations before, but not necessarily systems of inequalities. So here we go. We've got some modified notes set up, and I went ahead and I did a couple of things. Problem 9-89 has us graphing two different inequalities. Okay, it's got us graphing this particular one, and I made these graphs ahead of time. This particular one in green, and I went ahead and did this particular one in purple. Okay, and you can see them right here. Okay, as I mentioned, this one is right here, and this one is right here. I've got a intercept of 5. I've got a negative slope. I went ahead and tested a point. This turned out to be true, so I shaded this direction. I have an intercept of -1, a slope of up 2 and over 3. This point when I tested turned out to be true, so I shaded that direction, right? Had the help of Desmos to do some graphing. The one, of course, difference is the greater than symbol right here, recall, means that this is a dashed line, okay? The thing that we're going to investigate today is, what if we needed to graph both of these things at the same time? Maybe for the purposes of application, right? It's often heard of that inequalities are considered constraints, meaning they might apply some sort of limitation in the real world. And in that particular case, what if, and you guys watching probably can think of a time in your life when you had to deal with more than one limitation or more than one constraint. And what we're going to look at is how that might confine us, or how that might take what we see as a half plane of solutions and give us a limitation on that. So I'm actually going to use these two things here, these two inequalities, and I'm going to graph them on the exact same coordinate plane. So I'm going to take both of these things, just going to copy them real fast, and I'm going to graph them on the exact same coordinate plane that I've got down here. I've got this blank one down here, and yeah, it's going to look like this. And well, we'll review some skills from some earlier lessons, right? I start with this first one, y is less than or equal to -x plus 5. So first thing I'm going to go ahead and do is I'm going to graph that intercept of 5, and then I'm going to use that slope. Now it's -x, which means my slope is -1, which means go down 1 over 1, down 1 over 1, down 1 over 1. And I don't know how you guys are, but I like to graph kind of as many points as I possibly can, and I'll even go up 1 and back 1. And this just gives my line a little bit more accuracy. Now before I go ahead and draw that line, let's look at our symbol. It's less than or equal to. And that less than or equal to symbol means I have a solid line, because of course it means that points on the line are a solution. So I'm just going to do this, draw myself a quick solid line, and ta-da! Before moving on to the next inequality, we've got a test. So I'm going to test, of course, 0, 0. And that is me asking, if I put in 0 for this and 0 for that, do I have a true statement? Well, let's see. I've got 0 less than or equal to -0 plus 5. 0 plus 5 is 5. Is 0 less than or equal to 5? It sure as heck is. So this is true. Okay? This is true, which means we're going to shade this direction. We're going to shade towards 0, 0. Now before I shade this time, I'm actually going to get rid of that, and you'll see why in a second. Let me try to shade a little bit more cleanly on this one. All right, so everything's looking good so far. I've got some shading coming in there. All right, and you guys can of course shade as good as you want, but there we go. We've got one nice clean shading. we've got one inequality graph, but as we mentioned already, this is a system of inequalities. So we got one more inequality still to graph. And you know what? Just for to make it stand out, let's do this one in blue. Okay, and that'll make it so we can really kind of track these things. All right. So I'm going to graph this one in blue, and I'm going to treat it, even though I've already got one graphed, like there's nothing there. Okay, so watch what happens here. All right, I've got a y-intercept of -1. Okay, that's not a big deal. I'm graphing that right there. And then I've got a slope of 2/3. So I'm going to go up 2 and over 3. So up 2 over 3. Up 2 over 3. And like I said a second ago, I'm going to go down 2 and back 3 just to kind of enhance the accuracy of my line. And if you're doing this by hand, you can of course graph these things with a ruler, right? And what I'm going to do here is just kind of connect these things. That first one was not so great. I'm going to connect these things with a dashed line, okay? And the reason, maybe you know already, but the reason I'm going to use a dashed line here is because this is a greater than inequality. Okay, this is a greater than inequality. All right, so check this out. Okay, here's what I like to do in this case after I've graphed my second inequality in a system. I'm going to go ahead and I'm going to dot 0, 0, 0, 0 is not on my line. I'm going to test that point. I'm going to say, okay, 0 greater than 2/3 times 0 minus 1. All right, 0 greater than, okay, -1. Yeah, sure is. That checks out. This is going to be a true point. So I'm going to shade that direction, okay? And check out what happens, right? I'm going to get rid of that. Try to get rid of it without getting rid of the shading. No, I can't, so I got to leave that on there, okay? I'm going to shade towards 0, 0, okay? So one more time with my purple highlighter. And this happens when we graph in pencil too, or shade in pencil. What are we noticing here? What are we noticing? Okay? What do you guys see? All right, look at that. Okay? Do you guys notice how I've got like nothing? I've got like what I guess I would classify as like light purple here and here. And then I've got right here what I would classify as dark purple. Okay? The dark purple is my region of interest here because that is where my shading overlaps. Now, what does that mean? Okay? That is a great question. What does that mean? Think about that for a second. That is where the black inequality was true, but that's also where the blue inequality was true. Okay? That's where we have both of those things true at the same time. And that is what we call our, solution region for our system of inequalities. Okay? So when you're doing this, you're going to be looking for where those shadings overlap. All right? And it's where your shading is the darkest. If you shade like I did. Some people, they get pretty fine with their shading, and they don't shade like these areas that I have over here that would be classified as like the light purples. And they recognize some of these things ahead of time, or maybe they draw arrows, right? It doesn't matter to me how you're doing this, and I don't think it's going to matter to your math teacher as long as it's clearly identified. And maybe I'll even more clearly, I'll go over this one more time and darken it up even more. Clearly identified what your feasible region there is, right? Your solution region is, right? Okay, so there you go. A little bit of practice with a little bit of a system. Okay, we've already verified it. We can check it in both of those things. We did so. Part D. Part D is a great question here. How can you be sure that the region is the only set of points that makes our inequalities, system of inequalities true? Because that is the only spot on my graph where both of them are true at the same time. Like, for example, if I'm talking about this region right down here, okay, that makes one of them true but not the other. If I'm talking about this region up here, right, that makes, again, one of them true and not the other. And then finally, this makes neither of those things true. So this is right here the only one that makes both of those things true. Part D is also a bit of a leading question into a really neat thing that we're going to look at in a second here. Think about the way that two lines intersect. All right? If you were to have maybe like a pizza, right? And you were to only be able to take your pizza cutter or roller or knife or whatever, and you only able to make 2 cuts on that pizza, what is the biggest number of slices you could cut that pizza into? All right, and in this case it happens to be 4. Okay, so there are no other regions that we don't see on our graph. We're going to draw one more of these things, and I'm going to go a little bit faster through this one, but I am going to do it the exact same way. So I've got a coordinate plane. I've got 2 inequalities here. The first is going to be, and I'll use red because why not? Y is less than x plus 2. So I'm going to graph that intercept 2. I'm going to go up 1 and over 1. If you guys need to, you can go ahead and pause the video at any time if you are taking notes. Maybe I'm going a little bit too fast. Okay, but it's a less than, so I'm just going to dash this line. Okay, and then one more time I'm going to test 0, 0, see if that makes this thing true. So is 0 less than 0 plus 2? Well, what is that really asking? 0 and 2 make 2. Is 0 less than 2? Cha-ching, it is. So this is a true situation. Okay, so I'm going to be shading downward here. Okay, and maybe to make this stand out, I'll shade in red. I'll be shading down here. Okay, so check it out. I'm completing this first inequality before I move on to the second one. Okay, and then this second inequality I'll do in blue, and we've got y is less than or equal to 10 and minus 3/4 x. Now here's the deal. I don't have the ability to graph 10 on my graph. You guys can see it only goes up to 7. So a couple options here. Maybe you're going to just do some estimate. This would be like 7, this would be 8, 9, 10 might be here. And I would go down 1, 2, 3, go over 1, 2, 3, 4. Go down 1, 2, 3, go over 1, 2, 3, 4, right? So I'd have something that maybe looks like this. All right, and you know, as I'm looking at my notes here, I'm seeing that maybe I didn't make the best, give myself the best graph here to do this graphing. But it's a solid line because it is less than or equal to. And now one more time, 0, 0 is definitely not on my line, so I'm definitely going to test 0, 0. Is 0 less than or equal to 10 minus 3/4 times 0? Well, 3/4 times 0 is just 0, and 10 minus 0 is 10. So is 0 less than or equal to 10? It sure as heck is. So I will shade down one more time. Okay, and that ends up being down here. Now that before you get too critical, I'm shading in 2 different colors on purpose. Let me explain why. Okay, because of course I'd be shading down over this whole line, right? And what you guys are going to see here, and maybe this stands out from the purple example on the last one, is I've got a red region, I've got a region with blue shading, I've got a region with no shading, and then down here I've got a region with purple shading, and these are where my solutions lie. Okay, so this would be the solution to the system. Notice, any point on that dashed line, not going to be a solution. Any point on this blue solid line would be a solution, and then anything out here in this field would be solutions. Okay, check this out real fast. There is a very, very interesting problem that we're not going to have time for in this video, but you've got a linear inequality and then you've got a quadratic inequality. Super duper cool to try to think about this question. How many regions can you create? What if you change that line, right? What if that line looks different or was oriented different? It's a super duper cool investigation, and we're just not going to have time for it here. But we do have some review preview realized real quick that I hadn't written the review preview down. So got a couple review preview problems for you guys to try. And again, designed to get you thinking and asking questions. Folks, thanks for watching. Have a great day.